If you're interested in getting started with LabVIEW on YouTube, there are many helpful tutorials and videos available that can help you learn the basics of LabVIEW programming. Here are a few examples of some popular starting content. LabVIEW Tutorial for Beginners, by the Engineering Projects. This video tutorial provides a step-by-step guide to creating a simple LabVIEW program for data acquisition. The tutorial covers the LabVIEW development environment, creating a user interface, and acquiring and displaying data. LabVIEW Basics, How to Create Your First V, by National Instruments. This video tutorial is designed for beginners and provides an overview of the LabVIEW programming environment. The tutorial covers creating a basic V, using data types, and adding controls and indicators. LabVIEW Tutorial, Introduction to LabVIEW, by Crazy Engineers. This tutorial provides a broad introduction to LabVIEW and covers the basics of creating a simple V, including creating front panels and block diagrams, using sub-VAs, and debugging. Getting started with LabVIEW, by Learn LabVIEW Fast. This video series provides a comprehensive introduction to LabVIEW and covers the basics of programming, data acquisition, and control systems. The series includes over 50 videos, making it an excellent resource for beginners. These are just a few examples of the many LabVIEW tutorial videos available on YouTube. By searching for LabVIEW Tutorial or LabVIEW for Beginners, you should be able to find many more resources to help you get started with LabVIEW programming. LabVIEW programs can be organized into different models or paradigms, depending on the application requirements and programming approach. Here are some of the commonly used models in LabVIEW programming. Data Flow Programming Model. This is the default programming model in LabVIEW, which enables programming with a visual representation of data flow. The data flow model processes data as it flows through a series of nodes connected by wires. Each node can represent a function, sub-VI or an expression, and the connections represent the flow of data between them. This model is ideal for applications that involve data acquisition, control systems, and signal processing. Event-Driven Programming Model. In this model, the LabVIEW program responds to events or user actions, such as button presses or sensor readings. The program waits for an event and executes the corresponding code. This model is ideal for applications that require a responsive user interface and real-time control. State Machine Programming Model. In this model, the LabVIEW program is divided into different states, and the program's behavior depends on the current state. The program transitions between states based on events or conditions. This model is ideal for applications that require complex sequencing and control. Object-Oriented Programming Model. In this model, the LabVIEW program uses object-oriented design principles to organize code into classes and objects. This model is ideal for applications that require complex data structures and encapsulation of functionality. Functional Programming Model. This model involves programming with pure functions, where the output is only dependent on the input and has no side effects. This model is ideal for applications that require mathematical operations, such as signal processing and data analysis. Overall, LabVIEW offers a wide range of programming models that can be applied depending on the specific application requirements and programming approach.